Now that you know how to find the inverse of a function, we now will be actually looking at, do all functions have inverses? At the end of this lesson, you'll be able to use calculus to determine if a function has an inverse. All right, first of all, before we even look at this, when I'm talking about a function, you can always switch the x and the y values around. What we're talking about is to see if a function has an inverse function. We want to know, like on this specific example, I did one of these first. Remember, I had a parabola. We reflected about the line y equals x, and then we've got this new function going on. So notice you can find an inverse, but the thing is, this inverse is not a function because it doesn't pass that vertical line test. So this specific problem right here, actually I would say it does not have an inverse because the inverse is not a function. So that's what we're going to be looking at in this lesson, is finding, if I find the inverse, is that inverse a function? Okay. To be able to tell that, first of all, a function has an inverse if and only if it is 1-to-1. It passes the horizontal line test. What I'm talking about with this one is, notice this specific inverse function didn't pass the vertical line test, but the original function didn't pass the horizontal line test, and that was pretty much, if I would turn that on its side, it kind of turns into the vertical line test. So if an original function does not pass the horizontal line test, then the function will not have an inverse that is a function. Okay. The second thing is f of f will be strictly monotonic. You guys are going to get really feeling cool that you get to use these big strictly monotonic terms now. Basically what that means is it's always increasing or always decreasing on in its entire domain. Then it is 1-to-1 and therefore has an inverse, because if a function is always going up or it's always going down, then it will always pass the horizontal line test. And if it passes the horizontal line test, then when you turn it, the inverse will pass the vertical line test. So pretty much this is what we're going to be using right here, is we would like to find that a function is always increasing or always decreasing, and the way that we will do that is to find the derivative, because if we find the derivative, we'll want to make sure that our derivative is always positive or always negative, and that for us will prove that a function has an inverse or does not have an inverse. All right, let's look at some examples. We are going to determine if the function has an inverse first without calculus and then with calculus. Okay, so the first thing that we're going to do on this one is we're actually going to go ahead and graph it, because if I'm not using calculus, I would like to see if it passes the horizontal line test. So we're going to go ahead and graph it. If you want to grab your graphing calculators, that would be fine. I'll give you a minute to type it in if you would like to. And then when we do, basically you're going to get a picture that looks something like this. When you graph it, I think that actually goes through 0, 0. Okay, so you're going to get a picture that looks something like that. You will notice that if I did the horizontal line test, this graph does pass the horizontal line test, so this definitely, it does have an inverse, okay? Because if I turned it sideways, it passes the vertical line test, blah, blah, blah. Okay, so now let's use with calculus. All right, with calculus, we would like to show that this function is strictly monotonic by showing that the derivative will always be positive or always be negative. So the first thing that we need to do is actually to find the derivative of this function. The derivative of this function will be x squared minus 6x plus 9. Okay, and then if I'm going to test, is it positive, negative, 0, whatever, we want to find a critical number. So I will set minus 6x plus 9. I'll set that derivative equal to 0. When I do that, I notice this factors into x minus 3 times x minus 3. That gives me a critical value of x equals 3. So I'm going to make my f prime chart just like I'm usually doing for increasing and decreasing. Plug 3 into it. If I test 0 into the first derivative, and again I suggest testing it into the factored form. If I plug 0 in there, I'll get a negative times a negative, which is a positive. And then if I plug 5 in, I'll get a positive times a positive, which is also a positive. So you will notice my, because f prime is positive, f is strictly monotonic. So I'm going to say, yes, this has an inverse, and we actually would like to explain why. The reason would be, since f prime is always positive, f is strictly monotonic. And if we would want to say it's always, f is always increasing or decreasing, that's fine, but I feel way cooler using the word strictly monotonic. So that's what I'm going to do. So that would be my explanation if I had to use calculus and justify my answer. All right, let's look at one more example. First of all, we're going to do this without calculus. So we actually want to graph it and see if this graph would pass the horizontal line test. And if you'd like to grab your graphing calculator to graph that, go right ahead. And you can just pause it and then come back when you're ready. When you graph this, you should get something that looks like that. It might be a little bit off, but that's going to be the general feel of what you're getting. And if you'll notice, I can just draw one horizontal line right away. And in 3 places, it does not pass the horizontal line test. So this would definitely be a no. And what this is doing is showing that the inverse would not pass the vertical line test. So this one would not have a function, an inverse. Okay, if I use calculus, again, what we're going to be doing is taking the derivative. So the derivative of that function up there would be 3x squared minus 1. We would like to find the critical number. So set 3x squared minus 1 equal to 0. I'll get 3x squared equals 1. I'll get x squared equals 1/3. If I take the square root, I'll get x equals plus or minus the square root of 1/3. Don't forget that plus or minus, because that's pretty key to this problem. Okay, so we're going to do f prime. I'll put negative square root of 1/3 on it and positive square root of 1/3 on it. Okay, I'm not sure what value this is, but I'm quite certain that -5 is to the left of it. So if I test -5 into my first derivative, let's see, I will definitely get a positive answer. If I test 0 into that first derivative, I definitely get a negative answer. And then if I test positive 5 in, I will also get a positive answer. So you will notice that this function is increasing and then decreasing and then increasing. So f is not strictly monotonic, so it would not have an inverse. So I would say no inverse, and the reason would be, I would say, since f prime is positive and negative, it's both signs, we know that f is not strictly monotonic. And if it's not strictly monotonic, it would not pass that horizontal line test. So hopefully now you can find the existence of an inverse function using calculus.